I'll tell you about how far to go with the homework. All right, so 6.3. Some of this you're going to notice we've done before. And I'm trying to do a little more discovery. So in our launch, these are things you already know. So I want you to find the x and y intercepts, state the degree and the leading coefficient for letter A and letter B. So go ahead and try both of those. So DP, how do you find x-intercepts?
It's like x minus 3, that would be 3.
Yep. And then what about 4 minus x?
Would be 4.
Yeah, it's 4. Thank you, William. And then you're going to set, so what you do to find x-intercepts is you set the factors with x equal to 0, okay? And Matthew, how do you find a y-intercept?
Set all x's equal to 0.
Good job. You're going to set all the x's equal to 0. So then, Nick, what would the y-intercept be on this letter A?
24.
Well, is it positive or negative?
Positive. Wait.
I have 2 times a negative 3 times a positive 4 times a positive 1.
Oh, it would be -24.
Negative 24. All right, degree. Elise, how would I figure out the degree if I have it in a factored form? Well, I could do that, but I'd rather not. I'd rather not multiply it all the way out. Is there another way we could figure it out without multiplying it all the way out? Good job. How many x's are there? I have 1, 2, 3, so it's third degree. Now to figure out the leading coefficient. All right, now this one, I didn't give you anything really tricky in 6.1 and 6.2, so now they are going to get a little more challenging. To do a leading coefficient, you take the number out front and then all the numbers in front of the x's. So be careful right here. This is a minus x, so that's a -1. So my leading coefficient is not 2, it's actually -2. All right, so let's do letter B. I have y equals -1/3 x times x minus 6 times x plus 1, the quantity squared. All right, so Avery, what are the x-intercepts here?
6 and -1.
Okay, but what about this x right here? So, do you understand what's been happening is you set x plus 1 equal to 0. That's where the -1 came from. And you set x minus 6 equal to 0. So guess what? You really do set x equal to 0 if it's just a factor x. Then, Brennan, what is the y-intercept?
Be -6 plus 2.
Okay, now how do you find a y-intercept?
So x is equal to 0.
Okay, so what about this x right here?
B 0. Meaning
Isn't the whole thing 0 then? Yeah. Okay, so what's interesting is, do you see where is the only place on a coordinate grid where the x-intercept and y-intercept are the same?
origin.
The origin, right? Okay, that's at the origin. All right, now let's try to see if we can figure out what the degree is here without multiplying the whole thing out. Anybody feeling confident? This is a little tricky.
4.
It's 4. How did you get that, DP?
Because the x plus 1 squared would be x to the second,
Good.
and then times x minus 6 would be x to the third, and then times negative 1/3 x is x to the fourth.
Awesome. Okay, good catch. Okay, if you have that x plus 1 squared, that really is 2 x's in there. All right, the leading coefficient. I'm going to get negative 1/3 times 1, and then that 1 in front of the x is squared. So this is a case where it is, in fact, negative 1/3. In the past, you have worked with second-degree equations, quadratics. In this chapter, we will be exploring the graphs of polynomials with higher degrees, like third degrees, fourth degrees, and so on. The goal in this lesson is to get a sense of what these graphs look like. So here's what I want you to do. I have 4 boxes here, and I want you to read the descriptions. And what do you notice? What do you wonder? So let me give you a moment. Look at all 4. Look at what it says the degree is, the x-intercepts. What do you notice? What do you wonder? All right. Anybody? Anything you notice? Or anything you're like, I wonder if this is the pattern. Anything at all? How about this? Something what I'm hoping is, do you see you have 3 of the 4 were odd degrees? The third, and the 5th degree. What do you notice about those 3 graphs? Compared to the bottom left when it was an even degree. Yeah, Brendan?
The range on the odd ones are negative infinity to infinity.
Ooh, nice job. Okay, so the range is negative infinity to infinity on odd. That's true. And on the evens, it had a high point and shoots down. What does that mean? If you remember our quadratics, do you remember it was up, and down, down? Remember we did our arms a little bit with these? What does the bottom left, if it's a down, down, what does that tell you about this 4th degree polynomial? There's something we can tell when it went down, down. Yeah. There's a negative leading coefficient. All right, cool. So this one had a leading coefficient that's negative to make it go down, down. All right, let's go through each one. Do you see there were 3 x-intercepts and the degree was 3? Here, I had only 2 x-intercepts, but it was a 3rd degree. So we have something. When you have a bounce off, is an even or double root. So this is actually 1, and then there's 2 roots there when it's a bounce off. So watch this. If I do 1, this is a 1 root, a 2 root, a 1 root. Do you see that does add up to 4th degree? If I have a double root. Then look at this one. This is a double. This is a single. This is a double. Do you see that does in fact add up to 5? We're going to learn a little bit more with that. Even degrees either open up or open down with what we call their end behavior. And odd degrees either do this or they do that with their end behavior. All right, now we're going to do a think, pair, share. The graph of y equals f of x is a polynomial function with exactly 3 x-intercepts. There's no more. You can't have it anywhere else. -3, 0, 2, 0, and 5, 0. F of x also has a y-intercept of 0, -4. Based on this information alone, what might the graph of y equals f of x look like? I want you to sketch 3 possible graphs. There's no other x-intercepts besides those 3. So I want you to come up with at least 3. And it's got to cross at 0, -4 as well. Scroll back up to the 4 boxes and take a look of what can happen, because you can't let this cross the x-axis somewhere other than -3, 2, and 5. So you might be drawing the wrong thing. But you could create a bounce off so that it doesn't cross somewhere else.
Does anybody have a charger? iPad charger? I'm trying to have mine to do my Zoom thing. Oh, you know what? Somebody told me this thing worked. Let's try this. Is there a plug back there? Can you go to the back, see if this works? I'm not 100% sure. Oh, you've got one right beside you there, Phoebe. Right there. Let's try it. See if it goes into the iPad. Somebody was telling me it would work. Oh, it doesn't? Okay, no,
All right, turn to your neighbor and share at least one. Hopefully you at least have one. And then if they had one you don't have, add theirs to yours. Okay, you're supposed to be sharing right now. Share at least one of them.
Yeah, I can't think of one. It's weird.
flip it.
Yeah, I have no idea.
All right, here we go. Here's one possibility. It can only cross at -3, 2, and 5 on the x-axis, but it's got to go through 0, -4. I also did this one. Whoops, I put that in the wrong spot. Look at this one. You see I did that? Does somebody have another one they want to share? Kind of describe what you did. There's infinitely many we could come up with. Anybody else have something? Gosh, we're so excited today. How about this one? So like if you can't have it, come back up. Or I could have gone straight down there as well. Do you see those are some options? Okay. All right, suppose we're interested in graphing the function y equals -1/2 x minus 2 times x plus 1 squared times x plus 4. I'm going to pause a moment, and I want you to find the degree, determine the leading coefficient, the x and y intercept, and sketch 3 possible graphs. All right, so now that you saw me do that on the last one, see how much of this you can do. Yeah. So, do you see in front of that x is a 1? In front of this x is a -1. That's where it came from. Yeah, you're welcome. The leading coefficient, so what's in front of that x is a 1, in front of that x is a 1, and in front of that x is a 1. So you'd have -1/2 times 1, 1, 1. The tricky part is if this would be 2 minus x, that'd be a -1, and in here, if I had, say, 3x plus 1, that 3 is going to get squared. If it were 3x plus 1, okay? All right, William, what's the degree of this one?
4.
4. Okay, this is degree 4 because I have 1x, this has 2, and then I have 1x here. The leading coefficient is -1/2, okay? Now, what if I had, let's say this, all right? What if I had y equals -1/2, and let's say I had 3x plus 1 squared. Can you write this down just so we can kind of talk about, this is what you're checking for. Do you understand? If I want the leading coefficient, that's -1/2 times a 9, because that 3 is getting squared. So you have to pay attention to if there's something in front of the x inside the parentheses, okay? All right, x-intercepts would be 2, 0, -1, 0, and -4, 0. Now, can you tell at x plus 1 squared, that's called a double root. And I can tell there's going to be a bounce off at x equals -1. Okay, this one is called a double root. So these are the x-intercepts. Now my y-intercept, I'm going to let the x be 0. Did you get 4? So that's 0, 4. Now, at the -1, I now understand that that's a bounce off. Okay, that's going to be a bounce off. But I can't have any other x-intercepts. Now, do you understand, since it's 4th degree and a negative leading coefficient, this has to be a down-down? Okay, it's 4th degree, so it's got to be a down-down. Now I could make other squiggles. How might we make this a little more precise? Well, we could find additional points. Did anybody have a different graph that we could sketch? You could maybe have it go way taller somewhere. All right, so we're going to learn how to do that, and you are going to need a graphing calculator. You are going to need a graphing calculator today. Suppose we are interested in graphing the function y equals 2x cubed minus 2x squared minus 24x. Write this in factored form. So I'm going to pull out a 2x and get x squared minus x minus 12. So the x-intercepts are going to be 0, 0, 4, 0, and -3, 0. The y-intercept is the same as one of my x-intercepts, 0, 0. My degree is 3, and my leading coefficient is 2. So what we could do is we could plot more points. So let's plot what we know so far. 1, 2, 3, 4. Do I have any bounce offs? Do I have any place this is bouncing off? No, because I didn't have any double roots. Here's what I want you to do. Because I can't finish the graph until I know a little bit more, because this is y equals x to the odd, and it was positive out front, my end behavior is going to be as x goes to -infinity, y goes to -infinity. And as x goes to infinity, y goes to infinity. Because this is the x. Let me move this one down here. There we go. Because this is y equals x odd. All right, before I can finish this, this is where we're going to need our graphing calculators. But I'm going to give you some vocabulary first. So we have something called extreme values. Extreme values are your maximum and minimum. And we have two different types of max and mins. We have local or relative, which means in a neighborhood, you have a point that's higher than all those left or right of it. And then you have what's called absolute, or global maximum is the highest over the entire graph. This graph is not going to have an absolute max because it goes to infinity, and it won't have an absolute min because it shoots to -infinity. But it might have what we call a local or relative max. So here's what I want you to do. Take out your graphing calculators, and I want you to go, if you have the TI-84s, you're going to go to your y equals button. and we're going to go enter this graph. So you're going to hit this button. And so this is 2x cubed. Now to enter 2x cubed, you hit the caret key 3. Okay? 2x cubed. Make sure you come down from that and negative minus 2x squared minus 24x. And then you're going to press graph. Now we know, because it's an x cubed, a 2x cubed, it should look like this. And you might be seeing only part of the graph, right? Do you see it shooting up and then coming back, and then I see it go below? So you have to learn how to play with your window. So across the top, the tippy top, do you see a window button? I want you to press window. And I need to go higher on the Y and lower on the Y. That's called Y min and Y max. So once you press graph, you'll see like it's chopped. You can see it went above it. So what I want you to do is we're going to make a guess. On Y min, let's go to negative 40. And on Y max, let's go to 40. And then you should see a button that it represents Y scale. It's normally 1, but I don't want the calculator to make 80 tick marks. Let's change Y scale to 5. So I'm talking to the people with the TI-84s, okay, TI-84s. Along the top, you have window. The standard is negative 10 to 10, okay? So now, let's do that and then press graph. Ooh, oh, pretty good. Do you see? Now I can see the hill, but do you see we can't quite see that valley? So we're going to go back to window, and what should we change? Yeah, Drew? Y min. Let's change, make a guess to negative 50. We made a good first guess. Oh, that's beautiful, right? Okay, so now here's what you're going to do. So you have to learn how to play with the window. Sometimes it's hundreds, and you know, you've got to go to hundreds, and that's okay. So now, when you're on the graph, I want you to hit the second key and the trace key. Hit second and trace. Do you see there's a button that says minimum? So the calculator is going to find the minimum for me. So go to number 3, and now it says left bound. So what that means is you should see this little flashing cursor. And you just make sure the flashing cursor is somewhere to the left, close, but left of that minimum. So then you press enter, and you should see above it there's a little arrow. And then now move it, it says right bound. So just get it a little bit to the right and press enter. On guess, just press enter. And are you seeing 2.36 comma negative 41.49? Do you see that? If you got an error, you were not left of the minimum's still that little valley point. Anybody need help on the TI-84s? All right, now hit second and trace, and let's go grab the maximum. So now I gotta move using my arrow buttons. Arrow so that the flashing cursor is just a little bit to the left of that top of the hill. Press enter. Move a little bit to the right, and then now it's giving me a max of negative 1.69 comma 25.19. Are you getting that on your graphing calculators? So you need a graphing calculator for this unit. We're going to be using it quite a bit. So here we go. I'm going to write those down. I'm going to say there's a local max at negative 1.69, 25.19. There's a local min at 2.36, negative 41.49. So watch what we're going to do. That's the last piece of information to complete a graph, is what we call the extreme values. So now you're going to have to eyeball it, but then guess what? Do you notice I didn't put any tick marks on my y-axis? So guess what I'm going to do? I'm going to go 10, 20, 30, negative 10, negative 20, negative 30, negative 40, negative 50. And now we're going to estimate negative 1.69, 25, I'm going to put a dot up here, 2.36, negative 41. Now this comes from below, and then I've got my end behavior. All right, so now I'm being asked, where is the function increasing? We look at a graph from left to right, just like you read a book from left to right. So I want to know, where does this graph rise? Well, it's rising. Can I get eyeballs up here at the board, okay? This is rising from here until it hits that maximum point, right? Okay, this graph is rising from left to right, and then it rises again from the minimum up. So the way we describe increasing is with x values. So this graph is increasing, I'm just going to use capital I, from negative infinity to negative 1.69. I'm going to use the union 2.36 to positive infinity. And it's not because the infinity is not the up. The infinity is to the right. My negative infinity is not below. Okay, this is not the below. This is left, okay? So I'm using the x values. Now, where is the graph decreasing or falling? It falls between the max and the min. We're going to use the x coordinates to describe decreasing. So that's going to be negative 1.69 to 2.36. The graph falls between those two x values. All right, where is the function positive? A function is positive when the graph is above the x-axis. And again, we're going to use x values. That's between negative 3 and 0, and then again, 1, 2, 3, 4, 4 to infinity. So let me go over this again. Where is the function positive? Where are the y values positive? That's where the graph is above the x-axis. That happens between the x-intercepts, right here, from negative 3 to 0, and then it happens again from 4 to the right. Now, where is the function negative? It's negative everywhere to the left of negative 3, and it's negative between x is 0 and 4. So we're going to write it like that. So where is the function f of x negative? That happens from negative infinity to negative 3 and between 0 and 4. So we use x values for increasing, decreasing, and where the function is positive or negative. So we've actually almost covered everything we're going to do in this lesson, but we're going to take 4 days, okay? We're going to go nice and slowly through this. All right, so let's look at this example. If you're given the graph of the polynomial below and to the right, write down as much as you can. What are the x-intercepts? What's the y-intercept? Write the polynomial in factored form. You can then find the a value, find the degree and leading coefficient. Where is the function positive, negative? State the end behavior. Do as much of this as you can. All right, I'm going to go ahead and start this. The x-intercepts are at -3, 0, 2, 0, and 9, 0. The y-intercept is 0, -16. Okay, you just read those off the graph. Now, if I want to write the polynomial in factored form, because of the end behavior, do you see this is an up-down? That means it's an odd. And I don't see any bounce-offs, so this is going to be cubic. I'm going to go y equals a, and I'm going to have x plus 3, x minus 2, x minus 9. And then you're going to use 0, -16 to find the a value. I'm getting a is -8/27. So y would equal -8/27. X plus 3 times x minus 3, x minus 9. So the degree is 3, and my leading coefficient is -8/27. Where is the function positive? The function is positive from -infinity to -3 and between 2 and 9. Where is the function negative? That's between -3 and 2, and then 9 to infinity. Does that make sense where it's positive and negative? Above the x-axis, below the x-axis. State the end behavior. As x moves to the left, the graph is going up. As x moves to the right, the graph is going down. So we're going to generalize end behavior. If I have odd and a is positive, it looks like this. And we would say this. As x approaches -infinity, y approaches -infinity. As x approaches infinity, y approaches infinity. If a is negative, it's going to reverse. As x approaches negative infinity, y goes up. As x goes to the right, y goes down. If n, and here, do you see this is what I'm referring to, okay? If I have y equals a times x to the n, if n is even and the coefficient is positive, it's an up-up. So as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to infinity. If the coefficient is negative out front, these both go down. So here's my big idea. It's x odd, negative x odd, x even, negative x even. Didn't we do this year already? We did. All right, so x odd, negative x odd, x even, negative x even. All right, we have what's called the leading coefficient test. Without graphing, determine the end behavior. So if you look at letter A, and I have y equals 4x cubed minus 3x. I look at that highest power term. It's degree 3. I have a leading coefficient of 4. So without using a graphing calculator, this is my down up. So I would say, as x approaches negative infinity, y goes to negative infinity. As x goes to infinity, y goes to infinity. All right, then on this one, the leading coefficient is negative. My degree is 4. So this is going to be a down, down. Does this make sense? Is this like coming back to you from what we did earlier? All right, try the last two, part C and D. Try and give you a quick head start. All right, so my degree is 4. The leading coefficient is 7. So it's going to have an end behavior of up, up. So as x approaches negative infinity, y approaches infinity. This one, my degree is 7. The leading coefficient is negative 4. So this is an up, down. So as x moves left, y goes up. As x goes right, y goes down. All right, what I'd like you to do is pull